All right, guys, welcome back. So today we're going to pick up kind of where we left off with midpoint. If you remember before break, we were looking at the definition of midpoint, what it meant, and how to use it in various scenarios to figure out segment lengths, to set up equations. So today we're going to look at applying that to word problems. We started this kind of right before break, but then we were closed. And I also acknowledged that the assignment that was posted for you wasn't coming through correctly on the online version of Word. So we're going to kind of pick up where we left off, but I thought it would be helpful to kind of refresh your memory about the definition of a midpoint and how it is used. So taking a look at this Snickers bar, who doesn't love Snickers, right? If you were going to share this with somebody, you would break it down the middle, right? And so that you would have two equal pieces. Well, a midpoint is kind of like that same idea. If I was looking at given the measurement or amount, let's say this left-hand side, just for sake of ease, let's go with a measurement. Let's say if on the left it was 2 inches long, then whoever you were sharing it with would also expect 2 inches. So again, 2 inches would be equal to 2 inches. So definition of midpoint, it's kind of that same idea, is that it defines the middle of something and it creates two equal and congruent parts. So we'd looked at, you can set up equations that one side, whatever the value is, should be equal to the other side. Now in this example, you can see 2 inches is equal to 2. 2 is equal to 2. However, in math, we know it's not always as straightforward. So sometimes you're given an expression and you're given a standard value, and you hopefully should remember that we can set up equations to help you solve for unknown values. So that's where we're going to take a look at. So let's dive into how this applies to some word problems. All right, so if you take a look up here at the top, we've got a picture of a road, and I've put a little line above it just so that you can kind of see, how we're going to plot our points and how we're going to label it. So let's say A says the scenario. It says if Brentwood High School is exactly in the middle of Moore and Elroy Elementary Schools, draw and label the points above. So again, we've acknowledged that the high school. Oh, I'm moving my screen here instead of writing on it. The high school, and if you notice it is represented by the letter H, is exactly in the middle of Moore, which is an M, and Elroy. Now, hypothetical. It may not exactly be the same distance in real life, but we're kind of using this example as something that you're familiar with. Then we're going to label the measurements. Again, we don't necessarily know exact measurements, but it tells us from H to M, it's 18 minutes. So again, from H to M, Moore to the high school, it's going to take you 18 minutes to walk. And then it also tells us that from H to E, so from H to E, it's going to be 4x minus 2. So this is the expression that is given to us for H to E. So we're going to set up an equation and solve for x using what we know about midpoint. So again, just like the Snickers bar, 2 inches was equal to 2 inches. This time we don't have 2 and 2. We have the values 18 and the expression 4x minus 2. So we're going to take those two numbers and we're going to write an equation so that we're able to solve for that unknown value. So again, it doesn't matter where you put or what side you put each value or expression. Usually I typically follow how it is in the picture that is drawn. So 18 is equal to 4x minus 2. Hopefully you feel solid enough in your equation solving skills and you remember how to solve two-step equations. We did review this before break, and most of you did really well with this. So the first thing that we do is, again, we look at the side with a variable and we look to undo addition subtraction first. So if you notice I jumped ahead just for a minute there, and I'm going to concentrate on the minus 2, and to undo it or get rid of it, we do the opposite so that it cancels. So 18 plus 2 here on the left gives us 20, and our 4x is just going to drop down. Now again, my goal is still to get x by itself. You should notice the operation of multiplying between 4 and x. So the opposite operation, you would divide. And we end up with the answer, x is equal to 5. So applying it, kind of taking it a step further. So we figured out what the x value stands for. So now it's going to ask you some application questions. How long does it take to walk from Moore to the high school? So you can go back to your words in A and B, or we can go back up to the picture. Sometimes I think it is easiest to look at the picture. We all like visuals, right? So more to the high school, that was M to H. How long did it take? Hopefully you can see. It told us that it took us 18 minutes to walk. So that's just a straightforward answer. Then it's asking us how long does it take to walk from the high school to Elroy? So from the high school to Elroy, here's the high school to Elroy, it gave us an expression, 4x minus 2. So what I'm asking for you to do is kind of plug in that expression. However, we now know that x is 5, right? So we could go back and say, all right, well, 4 times 5, here's my blue x value. We could evaluate it for that value of x. So if I go ahead and solve this, 4 times 5 is 20, minus 2 gives us a final answer of 18. Now I want you to stop and think for a minute, guys. We had talked about the definition of midpoint. Think back to our Snickers bar, right? Is that this side should be equal to this side. So 2 is equal to 2. So the distance here should be exactly the same as the distance here. So applying that to your problems, it would make sense, and I want you to think just logically and checking your work, that your answer for how long it should take you to walk from Moore to the high school should be exactly the same distance as from the high school to Elroy. So the idea that you come up with the same answer for the first two application questions makes sense, right? Because we have defined that the high school is directly in the middle. So it should take equal distance to walk to either elementary school building. The last question here in our apply, it says, find the time it takes to walk from one elementary school to the other. Well, if we think about what we learned earlier this year about segment addition, if we are looking at Moore, this takes us 18 minutes, another 18 minutes to get to Elroy, we would use the operation of addition. I'm adding those two segments, I'm adding those two time frames together to walk from one elementary to the other. So we would say 18 plus 18, and that's going to give us a total of 36 minutes. I apologize, my writing's a little rough there, but hopefully you understand the idea there, that the first, if it's asking about each segment, they should be equal to each other. And the last here, it's asking is the distance between one point on the end to the other end point, which indeed we know to add the segment. So 18 plus 18 is 36. All right, so let's take a look at one more. All right, now this is kind of set up, just so you're aware, this is set up very similar to your assignment. The only difference that you're going to see is that I had trouble getting it to the point where you can draw and label the line segment. Every time I tried, it shows up different on the online version. So what you're going to see is you're going to see a similar problem, but it's going to, the picture and the visual and the labels are going to be there for you. So step A is going to be done for you. But let's take a look at how we would set it up, and then we'll progress. All right, so it says Lana and Natalie split their street in half at the midpoint of M. So I would first kind of take a look at just this information. It says M is in the middle, and we have Lana and that's an L, and Natalie. All right, each walked around trying to sell candy to the neighbors on the street, and in the end, they both sold the same amount. Lana came up with $18. So Lana, here's her side of the street. She's selling to these people on her side of the middle, from the middle to her side of the street. And she said that she came up with a total sales of 18. Natalie said that the two customers on her side of the street, here's her side of the street, bought the same amount, and the other one bought 8. So it tells you the expression here of 2x plus 8 represents the amount of candy and income that she sold. All right, so part B and C, these are the parts that I'm going to be looking for you to complete on your assignment. And again, it's set up very similarly. And your picture is already going to be there for you because, again, I had trouble having you do that portion of the assignment. All right, so looking at B, it says set up the equation and solve for x. So our equation, again, we know that midpoints set values equal to each other. So we could say 18 is equal to 2x plus, it's getting rough there, 2x plus 8. Working through our equation, again, we look for the side with a variable, and we work with removing the addition and subtraction first. So I would subtract my 8 from both sides. 18 minus 8 is 10. It's equal to 2x. Undo my multiplying by division, and you should get 10 divided by 2 is 5. So unfortunately, I must have been a fan of 18, but I'm getting the same answer. X is 5 is the first one. Purely a coincidence, guys. But my X value in this particular problem as well is 5. Then you're going to move on down and answer your application questions. So the first one says is how much did Lana sell walking her half? So again, whether you go back to the visual or whether you go back to the narrative at the top, but Lana's side of her street is right here. She said to all these people, and it told you just point blankly like, hey, she sold 18. And then how much did Natalie sell walking on her half of the street? So here's Lana here on the right-hand side. Here's her half the street, and she had an expression, 2x plus 8. Ooh. Now again, we know what the value of x is. It is 5, so we would evaluate it for the value of 5. Working through this to simplify it, 2 times 5 is 10, plus 8 gives us 18. And again, thinking logically, they sold the same amount. These girls sold the same amount. So Lana's side is 18 and Natalie's side is 18. That justifies to you that your equation was set up and solved correctly. Now, if you plug in a value, let's say you accidentally made an error in part B and you found your value to be 2. When you plugged it in, if you did 2 times 2 is 4, 4 plus 8 is 12, red alert, right? These should be equal so that you would know that you made a mistake. But we didn't do it wrong, right? We've confirmed because we've got the answer of 18 that you did in fact do it correct. So I do want to see the evaluation, guys. I don't want you to get the memo that, hey, I'm just going to rate, my same answer for the first application question and my second application question. I do want to see you evaluating so that I know that you understand the concept. Okay, then the last question says, how much did the girls sell in total altogether? So again, we're looking for the answer of how much did they sell in their entire street. If the left-hand side, Lana sold 18 and Natalie sold 18 on hers, we would put those together. So we would get the answer of $36. And again, purely coincidence that those values happen to be the same. I didn't actually proofread that before I did my video, but hopefully, again, the concept makes sense to you that midpoint means you can set each side equal to each other, solve through, and you should also be able to use it to answer some questions. So good luck. Please alert me if your worksheet is not working out correctly. Again, you're going to have 2 examples to do on your own that are very similar setup to this last one that we just did. So please reach out if it's not working or if something is, showing up wonky when you open it online version. So good luck and hope everything goes well.